Greetings, math fans. All right, so this is our next day of limits, and basically today's topic is finding limits of trig functions. Okay, so finding limits of trig functions. And there are basically three of them that you have to know. Okay, the first one I'm just going to give you. Its limit as x approaches 0 of sine of x over x. Okay, you can analyze it actually using your graphing calculator. And if you, let's do that actually. Okay, so what I want to do is investigate when x gets closer and closer to 0, what happens to sine of x over x. All right, so let's actually graph that. So we're going to y equals, and make sure before I do that, actually make sure you are in radian mode. Okay, so you're going to hit y equals, and we're just going to do sine of x, close parenthesis, divided by x, and we're going to hit zoom. Let's do zoom trig, zoom 7. Okay, interesting. So we're looking for it as x approaches 0. So at the top of this little bump right here, we're kind of trying to see what's going on here. And so, if you want to investigate it a little bit, we can do second calculate value, and then you can type in x value. And so let's put in 0.1. Let's get kind of close to it. 0.998. Well, we don't. All you have to do is type in another number. So 0.01. So 0.998. 0.9998. Let's do one more. 0.9999993. So it looks like it's going to 1 when you're coming from the right side. Let's look at the other side. How about negative 0.1? Oh, same 0.998. How about negative 0.01? Well, so you can kind of see what's going on here. Let's do one more, negative 0.001. All right, so it's going to 1. All right, so graphically, just showed you on the graphing calculator that it goes to 1. Now, there's a special theorem out there. It's called the sandwich theorem or the squeeze theorem, depending on if you want to give somebody a hug or if you're hungry, depending on which you use which one. But it actually is called that. And it investigates what's going on. You can come up with a function that's almost the same as sine of x over x. And if it's the same and it's on both sides of it, the limit is the same, you can actually sandwich and find out the value of sine of x, okay, over x. Not going to get into that. That is for another time, another place. Right now, just investigating with the TI, you know that this is equal to 1. Okay, so that is super important. You need to know that. Now, before I get to the next kind of or next trig function here, am I allowed to do this? Can I flip it around like that? Well, sure. If something equals 1 and you flip it around, doesn't it still equal 1? It's like saying 5 over 5. I flip it around, isn't it still 5 over 5 is still 1? Now, if it was anything different, it was like equal to 2 or some other number, you couldn't do that, all right? But it doesn't matter if it's x over sine of x or sine of x over x, they both equal 1, okay? The first one to know, very, very important. The one I want to come up with now is tangent. So limit as x approaches 0 of tangent of x over x. Okay, this is our polite trig function, tanks, or the army trig function, tanks. Well, what I'm going to do is I'm going to rewrite that tangent of x. So limit as x approaches 0, write that as sine of x over cosine of x over x. Okay, and I'll put that as x over 1, so it kind of helps me a little bit to see how to rewrite it. I can say limit as x approaches 0 of sine of x over cosine of x times the reciprocal of that 1 over x. Okay, so I'm showing a couple steps here. Limit as x approaches 0 of sine of x. I'm going to put that sine of x over x with that. Okay, sine of x over x, because we already know that sine of x over x is 1. So remember, one of our properties was the product property for, or product rule for limits. I am allowed to split this up, so I can say limit as x approaches 0 of sine of x over x times the limit as x approaches 0 of 1 over cosine of x. Now, the nice thing about this one, knowing this one, is I don't have to worry about that. As long as I have a sine of x and an x, sine of x over x, I don't have to worry about having it undefined. I know that's equal to 1. So I can set that's equal to 1. And then what about limit as x approaches 0 of 1 over cosine of x? Well, that's kind of nice direct substitution, because what's cosine of 0? It's 1. So 1 times 1 is 1. So your other important one, so I'm going to put a little some stars around this guy, because that is really important. I mean, you can know the other one too, reciprocal, that's fine, I don't care. But this is another important one. So limit as x approaches 0 of tangent of x over x equals 1. Okay, that is really important. And again, you don't need to write, or you don't need to necessarily know this, because you should kind of know it anyway. Again, if I flip it over, it's also equal to 1. Okay, so you definitely want to put some stars around this guy. 18,000 stars, probably. Something like that. Okay, so that's the second one. So sine of x over x equals 1. Tangent of x over x equals 1. The next one, let's just cursor down here a little bit, is limit, let's do it in black here, limit as x approaches 0 of cosine of x minus 1 over x. So once again, can't do direct substitution because you got a 0 in the denominator. Now what I can do is, well, I can't rewrite cosine as anything. That would be kind of messy. Okay, but what I can do is I can multiply by the conjugate. So cosine of x plus 1. Again, as long as I multiply by the same thing top and bottom, I'm allowed to do that. Okay, and that's going to give me limit as x approaches 0. If I FOIL the top, I get cosine squared of x. Outside inside cancel, and minus 1 over x. Again, I'm not going to distribute. Cosine of x plus 1. Now, you guys should recognize from this, sine squared of x plus cosine squared of x equals 1. I can actually rewrite that, right? If I subtract 1, I move that over, so I get cosine squared of x minus 1, and subtract sine squared equals negative sine squared of x. Okay? And then I can do direct substitution. So I now have a limit as x approaches 0 of negative sine squared of x over x times cosine of x plus 1. Now what I tell you guys many times, our goal is to get rid of that x. Okay, we don't want a 0 in the bottom. That's the whole point. And before I was able to take out a sine of x over x. In fact, I do, look at that, I have a negative sine squared. So why don't I write that as limit as x approaches 0 and just take out a sine of x over x. That deals with part of that, and then I have limit as x approaches 0. What's left over is still a negative sine of x over cosine of x plus 1. So again, the beauty is I've dealt with that now, so truly that's just equal to 1. And now I'm not going to get something undefined in my denominator. What's sine of 0? Let's do the numerator first. Sine of 0 is 0, so I have negative 0, which is 0, over, what's cosine of 0? It's 1. So 1 plus 1. So you have 1 times 0 over 2, which is 1 times 0, which is 0. Okay? So you guys need to write this down, put lots of stars. Limit as x approaches 0 of cosine of x minus 1 over x equals 0. Also, what I could do is, sometimes people see this. Limit, I can factor out a negative 1. Limit as x approaches 0 of, if I switch it around here, 1 minus cosine of x over x. It's actually the same thing, math fans. Because think of it this way, if I factor out a negative 1 here, it would be like saying a negative 0, right? And it's still equal to 0. So either one of these is fine. And you definitely want to put some stars around this guy here too. Now, this is a thing that you got to be careful about. This doesn't work. See how I did reciprocals? I said tangent of x over x is 1 and x over tangent of x is 1. You can't do this. So let me get a little more room here. Limit as x approaches 0. This is really bad. X over 1 minus cosine of x. That is not equal to 0 because you can't take the reciprocal of 0. What's the reciprocal of 0? Undefined. Okay, so boo, don't do that. Okay, that can't happen. You can only have cosine on the top for these problems. Okay, so the rest of the lesson is actually based on these trig functions. All right, so let's do some, kind of keep them handy. If I gave you guys a problem before we actually get into too much crazy stuff, if I said limit as x approaches 0 of sine of 2x over 2x, and you're like, what? I got a 2 there. Well, let's kind of analyze this a little bit. Do you guys agree it's a double angle? And maybe you do, or maybe you don't. Hopefully you do. Sine of 2x is 2 sine of x cosine of x over 2x. Well, that's pretty sweet because the 2's cancel, and you can see I have a sine of x over x. That's pretty important. So I can say limit as x approaches 0 of sine of x over x times limit as x approaches 0 of cosine of x. Right? They're equal. The top and the bottom are equal now. And so, well, we already know this by definition now. It's equal to 1. And what's limit as x approaches 0 of cosine of x? Well, what's cosine of 0? It's 1. So 1 times 1 is 1. So notice, math fans, you had a 2 and a 2 here. So basically a general term, no solution required, is limit as x approaches 0 of sine of nx over nx. If these values are the same, it's equal to 1. They have to be the same though. And actually you can do the same thing, limit as x approaches 0 of tangent of x over x. So it's nx over nx. Right? That's not to a power. Make it clear. Tangent of nx. Okay? So, and that equals 1. But again, those coefficients have to be the same in order for it to equal 1. Very, very, very important. All right. So if I gave you a problem like this, limit as x approaches 0 of sine of 105x over 105x, what's it equal to? 1, because these numbers are the same. Okay? Now this is where it gets a little tricky, is if I said limit as x approaches 0 of 2 sine of 7x over 9x. And you're like, what? Ugh. Your goal here is to get a 7 in the denominator. Okay, I've got a 9. How do I get 7? That's brutal. Well, here's what you do. It's really easy. I'm going to just pull this out. By the constant multiple rule, I'm allowed to pull constants out in front of the limit. So 2/9 limit as x approaches 0 of sine of 7x over x. Okay, and I'm almost done. What do I need in the denominator? I need a 7. So I'm going to do this in a different color here. I'll put a 7 here, but you can't just multiply that by, you can't put a 7 there. You actually have to put a 7 to balance it out, right? Because 7 over 7 gives you 1. So what I have now here, math fans, is this, the limit as x approaches 0 of sine of 7x over 7x is 1. And then you just got to deal with this. So 7 times 2 is 14 over 9 times 1. So the answer is 14/9. It's easier than you think. Sometimes kids go crazy and want to cry and everything. Really pretty easy. So let's do another one here. Limit as x approaches 0 of, this is kind of a scary one, 37 tangent of 3x over 13x. Brutal! So what do? Take the 37 over 13 out. So 37 over 13, limit x approaches 0 of tangent of 3x over x. What do you need for that bottom? I need a 3. So balance it out by putting a 3 here. Okay, now I know this goes to 1. And I just multiply 3 times 37, which is 111, over 13. So multiply that out, I get 111 over 13. That's your answer. Not bad, math fans, not bad. Okay, so let's take a look at even a little more complicated one. Not that bad, though. Limit as x approaches 0 of 3 sine of 2x over 8 sine of 5x. What? Well, remember, in order for the limits to work, math fans, for sine and really sine and tangent, you have to have an x opposite it. Okay, now you can't just add an x in there, but in this case, because I have a sine on the top and the bottom, why can't I do that? So can't I write this as limit as x approaches 0 of 3x sine of 2x over 8x sine of 5x? Right? I can do that because what x over x is 1. No big deal. So now what I have is, and really what happens here, this belongs to this, right? And this one belongs to this. That's important. Okay, so now I can rewrite this as limit as x approaches 0. And I pulled the 3/8 out, so it's 3/8 times that, right? And then it's x sine of 2x over x sine of 5x. And what do I need for that sine of 5x? Do you guys agree I need a 5 here? Right? Let me put this in red. I need a 5 right here to balance out with this 5. And so I put a 5 down here to balance, to cancel, so that cancels out to a 1, right? And then I need a 2 here. So that means I need a 2 here. So I balance it out and put a 2 here. Okay, so I really haven't changed the problem at all, right? If I actually multiplied it all back together again, I would get the original problem. So now this actually equals 1, right? If you wanted, you could actually rewrite it separately. You could say limit as x approaches 0 of 5x over sine of 5x times limit as x approaches 0 of sine of 2x over 2x, and they would be 1 times 1. But anyway, it's 1 times, and then of course the fraction here, so it's 6 over 40, and I reduce that to 3/20. Okay? Not bad, not bad. Let's keep going here. Another little crazy one. Limit as x approaches 0, sine squared of 7x over x squared. Okay, so again, I'm going to, I have a sine squared, I have an x squared. But what you can do is, I can write this as limit as x approaches 0. I'm going to pull this 7, or I'm going to separate it, right? I'm going to say sine of 7x over x times limit as x approaches 0. It's a bad arrow. Sine of 7x over x. So we got everything there now. Okay? And let's just do our little magic here. So I need a 7 here, so I need a 7 here. I need a 7 here, so I need a 7 here. And these guys, of course, both are equal to 1. And that's 7 times that. And it's all multiplication times 7 times 1, right? So we get 49. That's my final answer. Okay? So again, you're always trying to get rid of that. And that you get rid of that by knowing that sine of x over x, limit as x approaches 0, is 1. Okay, otherwise there would be no other way to get rid of it. Okay, so not too bad, right? All right, a couple more. It's just all manipulating all these different trig functions here. Limit as x approaches 0 of tangent cubed of 2x over x squared. So again, let's kind of break it up. It's limit as x approaches 0 of tangent of 2x over x times limit as x approaches 0 of tangent of 2x over x. And then it's cubed on top, so it's nothing left on the bottom, so it's limit as x approaches 0 of just tangent of x, right? Or tangent of 2x. Everybody agree with that? So if I put it all back together again, I would get the original problem. And now we have to, get a number on the bottom here that matches that coefficient there, 2x. So there's a 2 there. There's a 2 there. And this one I don't have to do anything. And the beauty of it is, what is the, if I put a 0 in this spot here, what's tangent of 0? It's 0. Okay. So this is 2 times 1, right? This is 1 times 2 times 1 times 0. Well, of course, if I multiply all that out, what do I get? 0. Okay, you're like, what? All that work? But sometimes you got to do all that work and just to get a 0. It's okay. Okay, so a couple more here. Limit as x approaches 0 of 5 minus 5 cosine of x over x. And again, you guys should recognize, oh geez, I got a cosine. I need a 1 minus cosine over x, or cosine of x minus 1, and then I can actually use one of my identities. I know it's equal to 0. And sure, I mean, you guys are smart. You can even see it's limit as x approaches 0. I can factor 5 out of here. So 1 minus cosine of x over x. So truly, it's 5 times the limit as x approaches 0 of 1 minus cosine of x over x. And what is this limit? What we learned, it's 0. So 5 times 0 is 0. Okay? Alright, last kind of brutal looking one here. Limit as x approaches 0 of secant of x minus 1 over x secant of x. Now, you should look at this problem. Again, you guys are smart kids. You should look at this problem and go, wow, Mr. Curtis didn't teach us anything about cosine. Oh, but wait, what is secant? Ah, it's 1 over cosine. So let's turn it into things in terms of cosine. Maybe something will work out for us nicely. Check it out. So limit as x approaches 0 of 1 over cosine of x minus 1 over x over cosine of x. Okay? And now I want to eliminate my complex fraction, so I'm going to multiply it by cosine of x over cosine of x. It's my common denominator. And if I do that, I get limit as x approaches 0. Again, make sure you distribute. So 1 over cosine times cosine is 1 minus cosine of x. The bottom, the cosines cancel, and I get x. Hey, it's one of our identities. Sweet! I'm done. 0. Okay? So that wasn't actually that bad. So kind of showed you a little bit of manipulation with all these different trig identities, and with sine, cosine, and tangent, and make sure you guys are good to go with this. But that's it, math fans. All right, have an outstanding day. Adios. Goodbye.